Hello again. In this video, I will be trying to determine the battery voltage and the voltage across resistor number 3 in this circuit. So it's a bit different example than the one before I solved. Normally the battery voltage is already provided, but in this case, I have the value or the magnitude of every single resistor in the circuit and the total current being given. So this total current, 1 milliamp, is the current will be shared between all the resistors. But the battery voltage is missing. Still, we need to apply Ohm's law, where the voltage of the battery equal the total current multiplied by the total resistance. So our equivalent need to be provided here, which means I need to do the equivalent resistor or find the total resistor in this case. So to do so, we have to find how much is the total resistance in this circuit. So as a start, we can try as usual go to the opposite side of the battery where R3, R4 and R5, but in this case we also can start with the resistor 1 and resistor 2 as they are a unit together. We can finish them quickly and find that what's the total of these. But I will keep following the same policy I mentioned at the beginning. I will start with the opposite side of the battery. So as a start, I have R4 and R5. They are in series, and I will call their equivalent as equivalent 1. Now, just to save the time, the R equivalent 1 in this case, I have 1.5 kilo ohm plus 560 ohm. That will give me about 2 kilo ohm. The R equivalent 1 and resistor number 3, they will be in parallel, and they are giving me R equivalent 2. I will name it, and because they are in parallel, and we're going to use the inverse situation, or I can say R3 multiplied by R equivalent 1 divided on their addition, I can get 1.32 kilo ohm resistance. Okay. Now the other one is these R1 and R2 as one unit. I can say, all right, R1 and R2 in parallel, sorry, and they will give me R equivalent, I will name it 3. Now R equivalent 3, the third equivalent in this scenario as part, then we will build up the total. It will give us about 600, let's say 88 ohm resistance. So now my circuit will look like this. I have my battery with the missing voltage, and I have the equivalent number 3 resistance, and here the equivalent, I can fix this one, it's the equivalent number 2 we said, and closing my circuit. Now I know the total current is still, it's the 1 milliamps. All right, so this is what I have so far, and I can see that R equivalent 3 and R equivalent 2, they are connected in series, which means I can find the R. Let's write this one. R equivalent 3 and R equivalent 2, they are in series, and that will give me my total resistance. And we're just gonna add them. So I can say 688 plus 1.32 kilo, and that will give me about 2 kilo ohm. That's my total resistance in this case, or in our scenario. Right? So I ended with a circuit like this: a battery with one resistor and the current. Now, how do we find this battery voltage? Well, I have the current and I have the R equivalent. You just simply 1 10 to the power minus 3. You multiply it with the 2 10 to the power 3. That will give me total 2 volt. So that's the total voltage provided by the battery. So we managed to find how much is the voltage across this battery. Now the second part of the question is to find the voltage across R3. So here is resistor 3. It's here. Now to do so, or to do such things, I need to reverse the process and start expanding my circuit. So step by step, if I'm going to start from this circuit here, the simplest one, R equivalent, and go step back, my step back will be here, where I have the R equivalent 3 and R equivalent 2 in series as the reverse step. So let's try to do that. I'll put just a line here. Yeah, maybe I can change the color. Now we said we're gonna move from this simple one to the just one before. This one was the R equivalent 3. This one the R equivalent 2. And I know my battery voltage now. I know the total current going through the circuit, all the detail I have. Now, I could go and calculate how much the voltage across the equivalent 3, but it is not required in this question. It's really gonna be, I'm spending my time on something not needed, so I wanna save my time. I'll focus and try to find how much is the voltage across resistor number 3. And to do that, I will say voltage, to calculate voltage across, equivalent to. The voltage for equivalent to will be the current, the total current, because they are in series, multiplied with the R equivalent to. Now the total current is 1 10 to the power minus 3. And the equivalent resistance 2, when we did the calculation, it was here. It's one here, and it was 1.32 kilo ohm. We just want to put 1.32 10 to the power, 10 to the power 3. And when we do the math, that will give us, very simple, it is 1.32 volt. That's the voltage across the equivalent to resistance. Now, let's expand this one here. I will be doing expansion for this one. So if I expand this one, it will give me the combination of R3 and what we called R equivalent 1 at the start. That was what R equivalent to coming from. It was coming from this combination. Let's go step back. This here area, the R3 with the R4 and R5, but R4 and 5 we named it as R equivalent 1. So, and R3. Now, we use the advantage and our knowledge from what we know. When I have resistors connected in parallel, that's the mean. That means the voltage across these resistors will be same. And the voltage across R equivalent to, which is 1.32 volt, is the same voltage, the voltage across equivalent to will be same the voltage across resistor 3 and also the voltage across equivalent 1, which is 1.32 volt. So there is no real need for more calculations or trying to add more items, finding the current or going here and there. I'm just using the fact that two resistors are connected in parallel. They will have the same voltage, and that's it. Okay? I hope you enjoyed this example and learned something different in it. And we'll see you in other examples with different subjects. Thank you.